By the end of this lesson, you'll be able to find a gradient, also called a slope, of a straight line. You'll also be able to find the angle made by a straight line to the horizontal. We have here in the XY plane a line segment AB that is inclined to an angle theta to the horizontal. We see in the triangle ABC that the side BC having length y2 minus 1 y1 is opposite to the acute angle theta. Remember that in one of our meetings we mentioned that the tan the acute angle is equal to the opposite side divide the adjacent side. We see in the figure that the side AC is adjacent to the angle theta, and so that's what we have in the denominator here. Now, this definition tan theta equals change in y divide change in s is what we are referring to as m. M represents the gradient or the slope of a straight line, in this case gradient or slope of line AB. Now, what's the meaning of gradient? Let's have another figure. In this figure, the first straight line is inclined to a certain angle to the horizontal. Let the angle here be 45 degrees. Let the angle made by the second line to the horizontal be 30 degrees. Now find the gradient M1 of the first line. M1 is going to be tan the angle that the straight line is inclined to. Tan 45 degrees gives 1. Now find the gradient of the second line. Gradient M2 equals tan 30. So the gradient M2 is going to give us 0.577. Now, how does the gradient of the first line compare to that of the second line? Gradient or slope of a given straight line describes the extent to which the given straight line is inclined to the horizontal. So in the figure, we see that the gradient M1 is greater than the gradient M2. Gradient simply means the extent to which a straight line is inclined to the horizontal. Now, a question for you. To what extent is the x-axis inclined to the horizontal? You realize that the x-axis lies on the horizontal. There is no angle between the x-axis and the horizontal. You can look at it this way. This first line over here, if we move it to lie exactly on the short dashed line, that's the horizontal line, the angle here will now tend to 0. And so tan theta will now be tan 0. Tan 0 gives you 0. And so the answer to the question, to what extent is the x-axis inclined to the horizontal? The answer is 0. The gradient or slope of the x-axis or any horizontal line is 0. Now we have here a first question. The gradient of a straight line is 1. To what angle is this straight line inclined to the horizontal? Gradient equals tan theta. Now question says gradient is equal to 1. So we now have our definition this way. We are to find the angle that the straight line makes with the horizontal, that's theta. So we take tan inverse of both sides. Taking tan inverse of both sides, we get 45 degrees. That's all. The angle made straight line to the horizontal is 45 degrees. And next question, the points K and L are points in the xy plane. Find the gradient of the straight line passing through K and L. Okay, so we mentioned that there are two definitions for gradients, y2 minus y1 divided s2 minus s1. The other one, gradient equals tan theta. For this second question, we see that the formula that we can use to find the gradient is this first one. Every coordinate is of the form s, y. K, let the point K be s1, y1. The second point L be s2, y2. So substituting into the formula, we get y2 minus the y1 value is minus 3, or divide s2 is 4 minus the s1 value is 10. And so we get minus 6 plus 3, which is minus 3 divide minus 6, which in 10 gives half, or 0.5. So this is the gradient of the straight line. And next question, the slope of the line joining the points P and Q is minus 4 out of 3. Find the value of M. Let the point P be S1, y1. The point Q be S2, y2. Again, we know that gradient is giving us change in y divide change in s, and it's also equal to tan theta. For this very question, we see that we can use the first definition to work it out. We don't need tan theta for this one. So now the question says that the slope, another name for gradient is slope. The slope is minus 4 out of 3. Now our y2 is m, minus y1 is 15, divide s2 is minus 9, minus the s1 value is minus 12. So we get minus 4 divided 3 equals m minus 15 divide 3. Now when we multiply both sides by 3, the fraction is cleared. So we now get the value of m to be equal to 11. It tells us that the coordinate of the point Q is minus 9, 11. Next question. The line joining the point Q and T is inclined at, let the point Q be S1, Y1, let the point T be S2, Y2. Now we have been given the angle theta. We are told that the straight line is inclined to 135 degrees. So gradient equals y2 minus y1 divide s2 minus s1, and we know that gradient is also equal to tan theta. Now substitute. Our y2 is 1 minus y1, y1 is 5, divide s2, which is 3u, minus s1, equals tan 135. So we get minus 4 divided 3u minus 8. Tan 135 gives us what? Tan 135 gives us minus 1. Now when we cross multiply, we get minus 3u plus 8, which in turn gives 3u divide both sides by 3, you get a value of u to be 4. It tells us that the coordinate of t is 3 multiplied 4 gives you 12. So the coordinate of t is 12, 1. Means that the gradient or the slope of a straight line is denoted by the letter m. This straight line in the figure, the end points are A and then B. So it means the gradient m is going to be, this is how it is calculated. Take the difference in the y coordinates. Point pick y2, do minus the other y value, y1, divide s2 minus the other s value, s1. What you should note is that finding the gradient or the slope of a straight line, you can use any 2 points at all on the straight line. So if I have a point here C, a point here D, a point E, a person can decide to use D and E to find the gradient of the same straight line. Or you can use C and D, you can use C and B. Any 2 points can be used. Any 2 points on the straight line can be used to find the gradient of the straight line, also known as the degree of inclination to the horizontal. Now, we also made mention of a second formula for finding the inclination to the horizontal, the gradient. Let the line AB be inclined to an angle theta to the horizontal. Let the line segment AB be inclined to an angle theta to the horizontal. Then we will have the second definition for the gradient. Gradient equals tan theta. See you in the next lesson.